Okay, so here we have our two slide systems. This is our fertilizer slide system. This is called a 3-hole drop. And this is our winter slide system for salt. So for the moment, we're just going to focus on the fertilizer slider, or our spring-summer slide system. The difficulty with spreading fertilizer is that you have so many different types of fertilizer. I've just picked out 3 different samples, and as you can see, this one has a very large granule. This one is more of a medium granule. And lastly, we have something that kind of resembles sand. Now, why does this make a difference? The reason is because when it flows through the 3-hole drop at the top, this large granule here is kind of like a large ball bearing, or well, a small ball bearing. And it has a density to it that's heavier than our medium or light granule. Now what that means is that the ball bearing in the large granule is going to flow through our 3 holes at the top, and with our impeller spinning, it's going to hit the impeller and fly off quickly because it is a heavier granule. Now, similarly, but sort of on the opposite end of the spectrum, our sand is much lighter, so it's going to trickle through the 3-hole drop at the top, and it's actually going to stay on the impeller for longer. So what I'm saying is the large granule is going to flow more to the right hand side, whereas the light granule is going to stay on the impeller and come off later, and will actually go more on the left hand side. So to follow this logic through, if it's a large granule, you're going to throw more to the right, and if it's a lighter granule or a smaller granule, you're probably going to throw more to the left. That's if the impeller is flying anti-clockwise. Now, why is that a problem? The reason it's a problem is because if you spread all of your fertilizer on one side and it's not even, then you're going to get more grass growth on one side, or potentially even throw too much there and burn your grass, whereas the other side is not going to get enough fertilizer and enough nutrients to grow. So how do you fix this problem? Well, if you have a 3-hole drop, that basically means that you have a fertilizer spreader that's made for a mini granule. Now the reason it's made for a mini granule is because that is the most common. Where spreaders fall down is when you have a fixed 3-hole drop that has no adjustments on, because you run into the same problem with a large granule and a small granule. The only way to fix overspreading to one side or the other is to adjust the settings on your application. And what that will do is that will change where the granules land on your impeller. It will either bring it closer to the pinion or further away towards the edge of the impeller. And essentially by doing that, you can even up the spread pattern by moving where the granule falls on the impeller to make, for example, the large granule, you can move it closer so it doesn't go off as fast, and so it will stay on the impeller for longer and create a more even spread. Now, we test and test and test on our calibration machine to make sure you have the right setting to enable a completely even spread pattern. Okay, so we've covered fertilizer spreading and the reasons why we have the spring slide system, and why it's very important that when you want to try and spread fertilizer well, do you have these adjustments. And basically, Cresco offers the most comprehensive slide system available with 20 different settings, which essentially allows you to spread any type of fertilizer accurately. Next, we have the winter slide system. So we're going to get rid of these fertilizers here, and we now have salt. Now, salt is extremely difficult to spread. Essentially, salt just loves moisture, it grabs it from everywhere. That's why we spread salt in the first place, because it soaks up all the moisture and stops things from freezing. The problem is that before you spread it, it will try and grab all the moisture it can, and it will clump together, and then it becomes extremely hard to push through any application hole. That's why you always want a large application hole when spreading salt. In our push spreaders, the only way to get the salt through the hole is through gravity. That's the only force going through the hopper. If you compare that to sort of large gritters, for example, there's a lot of mechanical software in there. You have an auger system that's kind of like a corkscrew, pulling that salt manually through the application hole on a large gritting machine. Another way big gritters keep salt from clumping together is through vibration. A lot have vibrator units on that kind of do this to the hopper, which will keep the salt moving and keeping it loose and malleable. Unfortunately, we can't do that with a plastic push spreader hopper because the hopper will break. So the best case scenario is you have a large application hole with a good agitator in the bottom of the hopper, just doing the same thing, kind of trying to keep the salt moving and stop it from clumping together. On this winter slide system, you can half the spread width. Now the problem with doing this is that, as you can see, it makes your application hole smaller. So you do want some pretty good salt. For example, here we have white marine salt, which is very dry. You wouldn't be able to use this with grit. It will make it too hard to spread. But again, if we put it back to our large application, that will give you the best opportunity to spread salt with any kind of moisture in it. So to show the difference between how easy it is to spread dry salt and wet salt, we'll do a little experiment. You can see how malleable this salt is, and that's because it's very dry. We've had a very dry summer here in the UK, and it's been sitting in our warehouse. So now it's the perfect sort of moisture content. We're going to take this, we're going to pour a bit of water in, and then we'll see how easy it is to move within this bag. Okay, so we've got some water, and we're going to pour some water in there. Close it up. Okay, so as you can see, it's sort of become this slush that kind of moves as one. If I try and slide it from side to side, it kind of all goes together. Now, if you have a lot of weight trying to push it through a small hole, you see how it won't slide through. If it was fully dry, you would get a sink through the hole because the salt can move better. Okay, here we're going to talk about flow of material through the application holes onto the impeller and why agitation is important. Now, the reason it's important is because you want a consistent flow of material through the application holes onto the impeller. If you don't, this impeller is going to be moving at a constant speed, or at least it should be, because you should be aiming for around 3 miles per hour when you're walking. Now, if I'm sprinkling something onto here consistently at the same rate, it should spread in the same manner. If, on the other hand, I have an inconsistent flow of material onto here and it sort of sporadically falls onto here, what will happen is you'll create a situation where the impeller, it seems like the impeller is doing that. You will get pockets of material thrown out, and then it will wait until the next bit of material drops down. The way you create good flow is by constant movement in the hopper down through these holes and onto the impeller. And the thing that helps regulate that is the agitator.